everyone. So now we continue to our next part or our second part of our chapter 1, fundamentals of logic. So now I will introduce to you the application, some of applications of propositional logic. First is to translate the English to propositional logic. Second, for the system specification. Third, Boolean searching, and fourth is for the logic circuits. So we go to the first one. So basically, logic has many important application in computer science and numerous other disciplines. And in computer science, we use the logic to specify the software and the hardware. And then the rule of logic can be used to design the computer circuit, to construct computer programs, and to verify the correctness of program and to build expert system. Logic can also be used to analyze and solve many familiar puzzles. Alright, for the first applications, which is to translate the English sentence. English or an other human language is often ambiguous. Steps to convert an English sentence into a propositional logic. First, you have to identify the atomic proposition and represent using a propositional variables. And if you still remember, in my first video, I do represent a sentence into a variable. Alright, so that would be the first thing that you have to do. And then the second part is you have to determine the appropriate logical connective. It's either conjunction, disjunction, or apa tu nama dia, by apa tu ingat, what was that, by conditional, or it is a conditional. Alright, so that will be the two steps to convert an English sentence into a propositional logic. So in this case, in this example I'll give to you is, if I go to Harris or to the country, I will not go shopping. So this is the statement or the proposition you have. And then the first thing you have to determine whether the sentence is a proposition or not. So in this case, it is a proposition. Then the second step is you need to assign the proposition variables into the proposition. Alright, so in this case, you may have 3 variables. First, if I go to Harris, and second, if I go to other country, and the third one is if I will not go shopping. So I have already assigned the P, the Q, and the R to each of the proposition. So this sentence can be presented into this one. Alright, P disjunction Q, you have bracket. If P or Q, then negation R. So if I go to Harris, or I go to other country, I go to the country, then I will not go shopping. Alright, okay. So this is a way for you to translate from English sentence into a proposition logic. Alright, so another example here. Okay, I leave this example to you. Okay, this is a very simple example. Alright, the second application for the logic is system specification. Okay, this is very important, especially when you want to develop the hardware and software system. Alright, and basically you will receive a verbal or a natural language from your customer or your client. Then your job is to identify and to clarify, not to clarify, but to identify which requirements or demand from the client, and also for the hardware or the software itself. Okay, the very first thing that you have to know is or to do is to make sure that the system or the spec of the system must be consistent. So you can do this by applying the propositional logic. Alright. So in this case, I give you an example. The automated reply cannot be sent when the file system is full. Okay, so this may be the requirement for the hardware. Alright, so the automated or software. Okay, so the automated reply cannot be sent when the file system is full. So automatically you can see you must assign two variables into this proposition. Okay, first, the automated reply cannot be sent. P, you can assign, let's say we use the P, and then the Q is the file system is full. Alright, so the P is automatic reply cannot be sent. The Q is the file system is full. Alright, so this one you can use like this one. One possible solution that I wrote here is this one. We use the conditional statement. So if the file system is full, yes, if the file system is full, then the automated reply cannot be sent. Okay, this one should be cannot be sent. Or you also can say the you also can do something like P to Q, which is P is the automatic reply cannot be sent. This one you can denote this one. Sorry, so this part you can assign this as Q, and also this one you can send it you can assign it as Q. So you can do like this. Okay, and also you also can do like this. Sorry, yes, this one is cannot. This one, yes, this one right. This one, the example or the solution that provide here, this one, it's we use the negation. Sorry, because we use the negation, so we let the P in a positive sentence. Alright, so when we denote the P as the automated reply can be sent, then when we present the proposition here, then we have to add the negation here. But if you don't want to add the negation, then you can do something like this. Okay, there are multiple ways on how to declare, but the most important thing for you is to make sure that all the declaration must be consistent. Alright, okay, and then okay, another example here. Okay, a definition of the consistent. A list of proposition is consistent if it is possible to assign truth values to the proposition variables so that each proposition is true and does not contain any conflicting requirements. Alright, in these examples, we have three lists of propositions. The first one is the diagnostic message is stored in the buffer or it is retransmitted. Second, the diagnostic message is not stored in the buffer. Third, if the diagnostic message is stored in the buffer, then it is retransmitted. Alright, we let this part as a P, and then we let this part as a Q. So for the first proposition, the combination, the compound is this, P or Q, because it used or here. The second one, the compound proposition is negation. So we put as the sign line should be nice. In this one, I just put negative. If the diagnostic message is stored in the buffer, then it is retransmitted. So I put it like this, okay, in the condition. So in order for us to identify which option is consistent, then we can use truth table. So since that there are only two variables here, so when you use this formula, then you know that you will have four possible combination. Okay, because the n is equal to 2. Alright, so you will have four possible combination. So when you have do this truth table, alright, so you can see here when the P is false and the Q is T, then all this statement is true. So in this condition, if in this condition, we can say that this spec is consistent. Okay, in this condition, all right, if for you to ensure that the system can be run smoothly, then you will choose this spec. So meaning that the diagnostic message, yes. So yes, so this one is not very true. Yes. So in order to make sure that it can be fulfill all this proposition here, then we have to make the P false, the Q must be true. Alright. Okay, so another example here. I will uh, let you just to try this part. Okay. So and the third application is for web page searching. So if you notice when you I believe that everyone in this class, you have used Google internet. Okay, so at least each one of you have a Facebook, kan? So I believe that you don't have any problem Facebook or Google. You may have used these tools. Okay, so but if you do not have any experience on using Google searching, please let me know. Okay, don't hesitate to come to me and tell me that you never use Google. It's fine, but I'm assuming right now every one of you have experience. Okay, so sometimes when you want to do the searching, it will be good if you can use the connective term. Like in this example, if let's say you want to find a university in Mexico, and then the university must be new, then you can use what we call as a keywords plus keywords with the connective word. Right, like in this case, new and Mexico and university. Then the Google and then the web page or the web page or the Google will give you the list of new universities in Mexico. All right. Um, yes, the same thing in this page. I will leave it to you to read this. Okay. Okay. So we go to the final application, which is the logic circuits. All right. The logic circuits, I believe that every one of you have learned this in your form 5, if I'm not mistaken. So this basically a refresh session. So the electronic circuits, they have an input and output, and we present it as 0 and 1. Binary numbers, 0 and 1. 0 is false, 1 is true. So from 3 basic. Okay, so we have basic circuits, which we name it as inverter, or inverter gate, OR gate, and AND gate. Alright, and we can form a complicated circuits based on these 3 basic circuits. Alright, so you have to remember this shape. The inverter is the three sides like this, and then the OR is like this, and then the AND is like a D, alphabet D. Okay, the inverter, which is the NOT gate, takes an input bit and produce a negation. The OR takes 2 input bits and produce the value equivalent to the disjunction of the 2 bits. The OR. The AND gate takes 2 input bits and produce the value equivalent to the conjunction of the 2 bits. Alright, so this is the complicated, as I said just now. You can see this considered as complicated digital circuits because it combines the three basic circuits just now, and then it will produce one signal, the desired output signal. So you can see that we have the first one, we have two inverter gate here. So the Q here will become a negation Q, and then the R here will become the negation R, and then this P here will become an input, and the negation Q here will become an input to the N circuit here. Alright, so the output from this gate will become P, this one P, and negation Q. Alright, and then the next one, this output will become an input to the OR gate here, and also the negation R will become an input to the OR gate here. So you will get the output will become P and negation Q bracket or negation R. Okay, this is simple. Logic puzzle, this is like a quiz, so I will let you to understand this. Alright, so the next part is the propositional equivalence. So for this one, I will proceed with proceed in our next video. Alright, so thank you.